All right, here we go. 13.4. So we're shifting gears a little bit away from the unit circle and away from the coordinate graph, um, and looking more at like a floating triangle. It's not attached to an XY graph. So we're going to learn two laws, one today, one the next section. So we have law of sines today, and we're going to learn law of cosines in the next one. But this is the equation for law of sines, and it'll make a lot more sense once we actually see an example. But what you need to know is that we only use this formula when we have a number across from a number, and that will again make more sense when we see an example. But these are used on non-right triangles. So you can use sine and cosine with non-right triangles if you use these laws. Okay, so here's how it works. This right here, you'll notice, this is what I mean by a number across from a number. Okay, now let's back up over here, up to this top one. The same letter is always across from each other, but one is uppercase, which is going to be the angle, and then across from it is the lowercase version of that letter. Okay, so what letter would I write on the left over here? Lowercase n and lowercase d. Okay, so you'll notice in the formula that A is across from A, B is over B. So that's how we're going to do this here. So if we have 115 and 15, those are going to be together in the fraction. Now, what is going to come after sine? Is it the 115 or the 15? 115. It's always the angle in that position. And that's going to be over 15. And we want to find x. Okay, so x is a side length, so I know that's going to go here. Which angle would I put it with? 35, because it's the one that's across from x. So we have sine 35 right there. How do you think we solve these? We cross multiply. Okay, so we've got 15 sine 35 equals x sine 115. How do we get x by itself? Yep, we're going to divide by sine 115. Now, when you put this in your calculator, you have to make sure that you are closing the parenthesis that they give you. Most calculators give you this red parenthesis right here. You have to make sure that you close it before you hit divided by sine 115. So I want everyone to punch this in and see if we can get the right answer. What are we getting?
Negative 9.49.
Shouldn't be negative. 9.49. All right. Everyone able to get that number? Okay, this one right here. We're using the same thing on all of our problems today. So law of sines. So do we have a number across from a number? No. Could we have a number across from a number? Could we easily find out what that last angle is?
Yeah.
What do the angles of a triangle add up to?
180.
180. So tell me what this angle is after you subtract. How much? All right, so sometimes you'll have to do that very simple task. Okay, just subtract from 180 to find the last angle. So now we have a number across from a number, so that's always where we start. So we've got sine 51 over 10. Now we're looking for x, so we're going to use what angle?
84.
Yes, we'll use the 84 because that's across from it, and then we've got x. Okay, so let's cross multiply again. Let's make sure we're comfortable with this process. All right, so we've got 10 sine 84, and it's always good to put the coefficient in the front and not at the end so it doesn't look like sine of 8,410. Let's put the 10 in front. Get x sine 51, and get x alone by doing what? We divide. Okay, now make sure you close the parenthesis around the 84 when you punch that in. Is that what we're getting? Or do we get a different number?
Yeah, oh yeah, yeah. So it would be 12.8 or 12.8.
So this is okay? Okay, perfect. Okay. Now this one's a little bit different. Why? What's different about this one? We have x in the angle. Okay, so I'll show you how this one's just a little bit different. The setup is still the same though. So we start with what? Sine what? We're always going to start with the number that's across from the number. So we'll start sine 42 over 6. And then what? Sine x over 8. Okay, we still cross multiply. 6 sine x, 8 sine 42. Now what? What should we divide by? 6. Okay, remember sine x is one item, so we can't divide by 6 sine. They aren't connected together. They're being multiplied. So we divide by 6. Somebody tell me what it is. Give me 4 numbers after the decimal. Well, if you should. 8922? Is that right? I don't have a calculator in front of me. We're good? Okay. All right, now what are we going to do?
Sine -1.
Sine -1. Anytime you're missing the angle, you use sine -1 or cosine -1 or tan -1. So we'll do sine -1 of 0.8922, and that should give us x. How big is the angle? 63 point what?
15.
Questions there? We good on this slide? All right, last one. Okay, so this is our other formula, and I will give you the formulas. You just have to know how to use it. Now, let's take a look at this. So this A right here is not referring to angle A, okay? That's referring to the area, okay? So if we're looking at this formula right here, let's say we had a triangle. Let's just write any old triangle with ABC. Across from it, remember, are the same letters. So we have A here, C here, and little b here, right? Okay, now let's look at this formula and see what objects they're using. So we're using angle C, okay, so we're using this angle, and then what two sides are we using? A and B. Okay, now you'll notice it's not always going to be A, B, and C. For instance, on this triangle, we have Z, D, and G. But looking at this picture up here, what objects are we always going to use? We have an angle, and then what? The two sides that are surrounding that angle, right? So we're never going to use the angle and the side that's across from the angle. So looking at this picture, we have this 98 right here. What two sides are we going to use? 10 and 11. We're not going to use the one that's across from it. Okay, this is going to find the area of the triangle without our normal 1/2 base times height. Okay, so if we have this picture right here, our 3 lines of work would be the formula first, and then we have 1/2. You put in the 2 numbers you told me we're using, and then sine of the angle, and then we have our answer once we punch it in. What do we get?
54.46.
Is that what everybody else got?
Yeah.
54.46?
Yep.
Questions on that? On the test, I'm going to give you all three sides, so you're going to have to remember that we just used the two sides that are around the angle. Questions?